Hi friends, we'll solve problem on curvilinear motion. Just see what is given in problem. Position vector of a point which moves in xy plane is given by r bar equal to 5 by 4 t cube minus 2 by 3 t square I plus t raised to 4 by 16 j. Calculate the velocity and acceleration at t equal to 2 seconds. In this problem, this r bar is given in ij terms. That means this one r bar position vector is xi plus yj, where x value is 5 by 4 t cube minus 2 by 3 t square and y is t raised to 4 by 16. As x and y are given as a function of time t, therefore this problem comes under xy component approach. Solution is possible using xy component approach. Therefore, first step in solution, as r bar is xi plus yj, that means x what is given is equal to 5 by 4 t cube minus 2 by 3 t square. This is the equation number 1. And what is given next part is y, that is t raised to 4 upon 16. Say this is equation number 2. Now as x is a function of time t, y is a function of time t, finally you have to find out velocity and acceleration. What we'll do here, if we differentiate x with respect to time t, we will get component of velocity along x-axis, and if we differentiate y with respect to time t, we will get component of velocity along y-axis, that is in terms of time t. Therefore, differentiating equation number 1, dx by dt equal to component of velocity along x-axis, that is equal to, now we will differentiate 5 by 4 t cube. What will we get here? 5 by 4 into 3t square minus 2 by 3 into 2t. If we will simplify, what we will get here? Vx equal to, now 5 into 3 15, that means 15 by 4 t square minus, this becomes 4 divided by 3 t. Say this one is equation number 3. Similarly, if we differentiate this y with respect to time t, what we will get here? Dy by dt equal to, this becomes 4t cube by 16. That means Vy, what we are getting here is 4 by 16 means 1 by 6. That means can you say it is t cube divided by 4. This is equation number 4. Equation of x and y is given. Differentiating equation of x and y with respect to time t, what we are getting? Vx and Vy. Now again, if we differentiate Vx with respect to time t, we will get component of acceleration along x-axis, and if we differentiate Vy with respect to time t, we will get component of acceleration along y-axis. Therefore, if we differentiate now equation number 3, what will get here? dvx by dt, which is equal to 15 by 4 t square, that means 15 by 4 into 2t minus this 4 by 3 t, differentiation of t is 1, therefore what will get here? 4 by 3. That means dvx by dt is component of acceleration along x-axis. So what will get here? 15 to 2 is 30 divided by 4t minus 4 by 3, or this one is also written as, if we divide throughout by 2, or this one may be 7.5 is also possible. Say this is equation number 5. Similarly, Vy, if we differentiate with respect to time t, that is dvy by dt, 3t square by 4. dvy by dt is what? Component of acceleration along y-axis, 3 by 4 t square. This is equation number 6. That means Now what equations are available? X and y in terms of t, Vx and Vy in terms of t, and Ax and Ay in terms of time t. What is asked in problem? Find velocity and acceleration at t equal to 2 seconds. That means at t equal to 2 seconds we will find out Vx, Vy. We will get resultant velocity. Similarly, from equation 5 and 6 we will get Ax and Ay and resultant acceleration. That means next step, at given time instant t at t equal to 2 seconds. At t equal to 2 seconds, Vx, if we will find out, that is component of velocity along x-axis, it becomes what? 15 by 4 into t square, that means 2 square, minus 4 by 3 into t. T means what? 2. That means Vx comes out to be, if you calculate using calculator, this Vx is 12.33 meters per second. As answer we are getting positive, that means component of velocity is in rightward direction. Similarly, Vy, if we find out, substituting t equal to 2 seconds, this is t cube by 4, that means 2 cube divided by 4. If you calculate using calculator, this one comes out to be 2 meters per second. As answer is positive, this component of velocity upward. Now Vx rightward, Vy upward, that means resultant velocity will get in first quadrant. So graphically we will represent here Vx and Vy, Vx rightward, Vy upward. Resultant velocity will get in first quadrant. As resultant velocity will get in first quadrant, I will represent here, this is nothing but V. Simply applying Pythagoras theorem, we will get magnitude of velocity. See this angle what you are getting here, inclination of velocity, I will write by theta v. Resultant velocity V can be calculated as Vx square plus Vy square under root. Applying Pythagoras theorem, what we will get here? Square root of 12.33 square plus 2 square. If we calculate using calculator, what velocity we will get is 12.49 meters per second. And inclination of velocity theta v, this one we will get from this figure, you can say tan of this angle theta is opposite upon adjacent. Opposite means Vy, adjacent is what? Vx. Therefore theta v is tan inverse of Vy upon Vx. Vy is 2, that means tan inverse of 2 divided by 12.33. That means this angle theta v comes out to be, if you calculate using calculator, 9.21 degrees. As you are getting velocity at t equal to 2 seconds, what you have calculated up to this step is resultant velocity and inclination of velocity is horizontal. What is asked in problem? Find acceleration at t equal to 2 seconds. For that one, equation number 5 and 6 were derived, where equation number 5 is equation of Ax in terms of time t, and equation number 6 is Ay, means component of acceleration along y-axis in terms of t. We will substitute here value of t as 2 seconds in Ax as well as in Ay. What we will get here? Magnitude of components with direction. Therefore, substituting t equal to 2 seconds, that means at t equal to 2 seconds, using equation number 5, if we will find out what is Ax. Ax equal to, equation of Ax is 30 by 4 into t, t is a 2 seconds, we will substitute, minus 4 by 3. As we are getting t equal to 2 seconds, we have substituted. Using this one, if you will find out, you will get what? Ax. Using calculator, if you will find out what is component of acceleration, this answer comes out to be 13.67 meters per second square. Answer is positive, that means Ax is directed towards right. Ax. Similarly, Ay, if we will find out, equation of Ay is 3 by 4 into t square. T is 2. If I will substitute 2 seconds, what Ay will get here is equal to Ay. Substituting value of t and using calculator, if you will find out, Ay comes out to be 3 meters per second square. Now as you are getting this is 3 meter per second square and AY positive, that means direction of AY, this one is upward. Now AX and AY directions you know, therefore will represent graphically AY upward, this is AY. AX is in rightward direction, this is AX. Now using AX and AY, applying Pythagoras theorem, you will get resultant acceleration. That resultant acceleration what you will get here is in first quadrant. This is resultant acceleration A, and inclination of acceleration I will write by theta suffix A, where suffix A stands for acceleration. Theta A represents what? Inclination of resultant acceleration with horizontal. To find out magnitude of resultant acceleration, A equal to square root of AX square plus AY square, which is equal to square root of, now AX is 13.67, its square plus 3 square. That means resultant acceleration what you are getting here is magnitude of resultant acceleration and comes out to be 14 meters per second square. This is magnitude of resultant acceleration. Now if you want to find out what is inclination of resultant acceleration, where tan of this theta A equal to, tan means opposite upon adjacent, opposite is what? AY, adjacent is nothing but AX. If you substitute your values, AY is 3 and AX is 13.67. Therefore, tan inverse of this value theta A comes out to be, if you calculate using calculator, this is 12.3 degrees. That means what you are getting here, magnitude as well as a direction of resultant acceleration at t equal to 2 seconds. Before that one what we calculated, magnitude of velocity and its direction with respect to horizontal. Thank you.